After studying this module, you shall be able to know the importance of cost in firm's decision-making process, learn different measures of cost of production in the short run, differentiate between explicit cost and implicit cost, learn about the appropriate functional form for estimating cost functions, understand certain basic problems inherent in actual measurement of cost. Introduction. One of the key determinants of a firm's production and pricing is its cost incurred in the process of production. If the firm's manager believes that the cost of production is too high to make a reasonable profit, then she would try to minimize the firm's cost. In layman's language, cost is defined as the amount of money that has to be spent in order to produce something. In order to produce goods and services, firms needs to acquire many things, for example, raw material, electricity, etc. The sum of the value of all these is known as the cost of production. There are two broad categories of cost of production. First is the short run cost and second one is the long run cost. Both the types are related to the nature of inputs involved in the production process. The value of fixed inputs, which are discussed in earlier modules, these are inputs that cannot be changed within a short period of time, together with the value of the variable inputs are known as the short run cost of the firm. Whereas, if all the inputs can be changed in a period of time to increase or decrease the production of a firm, then the value of such inputs are known as the long run cost of the firm. This module basically deals with the firm's short run cost curves. Cost as opportunity cost. In a very general sense, cost is considered as what we give up to achieve something. Opportunity cost of a good or service is calculated by the alternative uses which are foregone by producing the goods and service. The price of a good or service can often be considered as its opportunity cost. In economics, when we consider the cost of production, we include all the opportunity cost of producing output. For example, when a firm hires laborers, the value of wages paid to them is considered to be an opportunity cost. It is said to be an opportunity cost because this is what the laborer would earn if he took up any other job. If the firm paid them less than this, workers would simply opt for alternative employment. Cost can be of two types, viz. Explicit and implicit. Explicit costs are the actual payments made to the inputs used in the course of production. For example, wages, rent, cost of raw materials, etc. Whereas, implicit cost or opportunity cost are the cost where no actual payment is made. Implicit cost are the value of the resources or inputs owned by the firms, where these values are determined by what the resources would earn in an alternate use. For example, if a firm uses its own land, it does not have to pay any rent on it. The rent this land could have earned had it been rented out is its imputed or implicit cost to the firm. Economists and accountants treat cost differently. Economists are concerned about the economic profits, which equals the total revenue minus total cost, where the total cost includes explicit cost plus implicit cost. On the other hand, accountants worry about accounting profit, which equals the total revenue minus the explicit cost. Different measures of short run cost. There are many measures of cost of production in the short run that are helpful in taking the production and pricing decisions. These measures are: first, total cost, which is also known as TC. Total cost is the cost incurred on producing a particular good or service. Total cost is the sum total of fixed and variable cost. TC is equals to TFC, that is total fixed cost, plus TVC, that is total variable cost. Total fixed cost. It is the cost incurred on the fixed factors of production. Recall, fixed factors are those factors of production that cannot be altered or changed in a short span of time in order to increase or decrease production. Total variable cost. This is the cost incurred on variable inputs. variable inputs are defined as the factor of production that can be altered or changed in a short span of time to increase or decrease the level of production. Average total cost. Average total cost is the per unit cost of a commodity. Average total cost is the sum total of the average fixed cost and average variable cost. Average total cost, that is ATC, is equals to TC divided by quantity, which is equals to TFC divided by quantity plus TVC divided by quantity, or ATC is equals to AFC, that is average fixed cost, plus AVC, that is average variable cost. Average total cost can be calculated by dividing the total cost by the total quantity produced or by adding the average fixed cost and average variable cost. Average fixed cost. It is the fixed cost per unit of output. That is, AFC is equals to TFC divided by quantity. Average fixed cost is calculated by dividing the total fixed cost by the quantity produced. Average variable cost. It is the variable cost per unit of output. That is, AVC is equals to TVC divided by quantity. Average variable cost is calculated by dividing the total variable cost by the quantity produced. Marginal cost. Marginal cost, that is MC, is defined as the change in the total cost when one more unit of product is produced. Algebraically, MC is equals to change in TC divided by change in quantity, which is equals to change in TFC by change in Q plus change in TVC divided by change in Q, which is equals to change in TVC divided by change in Q. The above formula for marginal cost shows that it can be calculated by dividing the change in the total cost by 1 unit change in the quantity produced. Alternatively, marginal cost can also be calculated by taking the ratio of the change in the TVC to the unit change in quantity, as by definition change in TFC is 0. In the short run, fixed inputs and hence fixed cost remains unchanged. Mathematically, marginal cost can be calculated by taking the first order derivative of the TC and TVC with respect to quantity. To better understand all the measures of short run cost, let us do a numerical exercise. Following is the data of a firm that produces milk. Table 1. Various measures of cost. Table 1 represents the different costs which are involved in the production of milk by a firm. Total cost increased with an increase in output. Up to 5,000 liters of milk, total cost increases at a decreasing rate or at a slow pace, but after that increases at an increasing rate or at a faster pace. The reason behind the behavior of the total cost with an increase in output can be explained by the law of variable proportion or law of diminishing marginal returns, which is discussed in the earlier modules. Initially, there is very little of the variable factor compared to the fixed factor, so that the law of diminishing returns does not set in. After that, with further increase in the variable factor, there is simply too much of it compared to the fixed factor, so that the productivity of the fixed factor declines and diminishing returns to the variable factor comes into play. That is why the total cost curve is S-shaped. Figure 1 represents the shape of TC, TFC and TVC. TFC is horizontal to x-axis as TFC does not change with the changes in the level of output. TVC and TC have similar S shape. To show the shapes of the TC and TVC, the above figure is divided into two sections. The first section represents the increasing returns to the variable factor, meaning that if the variable inputs are increased, output increased at a faster rate in this zone. The second section represents the diminishing returns to the variable factor, which means if variable inputs are increased further, the output increases at a slower rate in this zone. Up to 5,000 liters of milk production, diminishing returns do not set in and there is increasing returns to the variable factor. Hence, the shape of TC and TVC is concave up to this point. Beyond 5,000 liters of milk production, The shape of TC and TVC is convex and the curves are upward rising as diminishing returns to the variable factor starts to dominate. As output increases, average fixed cost declines throughout. This has been shown in figure 2. The reason behind the inverse relation between the AFC and output is that fixed cost always remains constant in the short run and does not change with the level of production. So if the output increases, the ratio of TFC to output will decline. Figure 3 represents the shape of the average variable cost curve. The ABC curve is U-shaped and the reason for this is the law of diminishing marginal returns. As long as increasing returns to the variable factor prevails, this curve is downward sloping, and when the diminishing return starts to dominate, the ABC starts increasing and curve starts moving upward. In between these two situations, the ABC achieves its minimum point. As shown in figure 4, the average total cost curve is also U-shaped. The reason behind its shape is that at a low level of output, average total cost is high because of relatively high positive fixed cost that have to be incurred on the fixed inputs even at very low levels of our production. At high levels of output, diminishing marginal returns to variable factors set in as there is too much of these compared to the fixed factor. Therefore, at high levels of output, marginal cost is high, which leads to the high average cost. In between these two extremes, very low and very high level of output, the average cost reaches its minimum. Figure 5 shows the behavior of marginal cost when output is increased. First, it declines and then increases with an increase in output. The marginal cost curve is also U-shaped, and once again the explanation for its shape runs in terms of the law of diminishing marginal returns. Relationship between ATC, AVC and MC. Figure 6 shows the relation between AVC, ATC and MC. Relationship between AVC and MC. If marginal cost is less than the average variable cost, then average variable cost is falling. If marginal cost is equals to the average variable cost, then the average variable cost is at its minimum point, that is, marginal cost cuts the average variable cost curve at its minimum point. If marginal cost is greater than the average variable cost, then average variable cost is rising. Relationship between ATC and MC. If marginal cost is less than the average total cost, then average total cost is falling. If marginal cost is equals to the average total cost, then average total cost is at its minimum point, that is, marginal cost cuts the average total cost curve at its minimum point. If marginal cost is greater than the average total cost, then average total cost is rising. Note that the above relation between total, marginal and average magnitudes is analogous to the relation observed between TP, MP and AP in an earlier module. Also note that the AVC and MC curves can essentially be viewed as the mirror images of AP curve and MP curve respectively. The AP curve first rises, reaches a maximum and then starts falling, corresponding to which the AVC curve first falls, reaches a minimum and then rises. Similarly, the MP curve first rises, reaches a maximum and then starts falling. And the MC curve is simply the mirror image as it first falls, attains a minimum and then rises. Now, why we need cost? The question here which rises is, why we need AVC and ATC in short run? In the short run, there are both fixed and variable inputs. Fixed inputs are always paid irrespective of the level of output. If average revenue is greater than the average variable cost at a level of output, it means that the fixed cost is covered at that output. So, firms should continue operation and not shut down at such output levels. The next question is, why do we need MC? Marginal cost is very important because the pricing decision of firms is based on the marginal cost and not on the average cost. In fact, The optimal output of a firm is attained when marginal cost is equals to the marginal revenue. You will learn the concepts of average and marginal revenue in subsequent modules, and then the usefulness and relevance of the concepts discussed in this section will become clearer. The next section is cost estimation. Total cost is a function of the level of total output and input prices. If labor and capital are the two inputs used in the production process, then total cost can be expressed as a function of output level and input prices as follows. TC is equals to F bracket Q, W, R bracket close, where TC is the total cost, Q is the output, W is the wage rate of labor, that is price per unit of labor, and R stands for the interest rate, that is price per unit of capital. Problems in measuring cost. Before discussing the method used to estimate the cost function, let us talk about two important problems that arise in measuring cost and also how to address them. First, the problem of inflation. When we collect the data for various input prices, these are in nominal terms. The effect of inflation is included in these nominal prices, and due to this, even though output remains constant, reported costs tend to rise over time. In order to estimate cost correctly, therefore we need to convert the nominal cost data into the real cost data, where real cost is a measure of cost without the effect of inflation. To change the nominal cost into the real cost, we can make use of an appropriate implicit price deflator as follows. Real cost is equals to nominal cost divided by the price deflator. Second, the problem of measuring the economic cost. This problem arises due to the difference between accounting cost and economic cost. Accounting cost only include the explicit cost for which the firm actually make payments, whereas economic cost includes the opportunity cost, and hence they consider both explicit cost as well as implicit cost. Suppose a firm uses its own family labor and does not pay any wage to them. In this case, the imputed wage, that is the market wage that family members would have earned had they taken up the alternate employment, will not be reflected in the actual reported cost. If there are two inputs, labor and capital, the total cost will be TC is equals to WL plus RK. Theoretically, the wage rate and interest rate should reflect the opportunity cost of labor and capital. However, in reality, the reported cost based on the actual payments tend to be different from the opportunity cost. This factor has to be taken into account and appropriate adjustments made while applying these concepts in the real business situations. Simple regression technique. Simple regression technique can be used to estimate the short-run cost functions using the firm level data on cost of production and on output. For example, as in table 1. Out of ABC, TVC and MC, if we are able to estimate one of the cost functions, then we can get the other two cost functions quite easily. To estimate the short run cost, first we assume that the average variable cost curve is U-shaped. Therefore, mathematically, we define the ABC as a quadratic function as follows. ABC is equals to A plus BQ plus CQ square. In this case, we will have a U-shaped ABC function if B is less than 0 and C is greater than 0. Given the ABC functions, we can find the TVC as follows. ABC is equals to TVC divided by Q. Hence, TVC is equals to ABC into Q. TVC is equals to A plus BQ plus CQ square into Q, which is equals to AQ plus BQ square plus CQ cube. This is a cubic function indicating that TVC will be a S-shaped curve. The marginal cost curve can be derived from TVC by taking first differential of the TVC function with respect to Q. So, the MC function can be obtained as follows. MC is equals to delta TVC divided by delta Q, which is equals to A plus 2BQ plus 3CQ square. So, you can see that once we estimate the three unknowns A, B and C, we can easily estimate AVC, ATC and MC. We can make use of the t-test and f-test to test the significance of these parameters. The TC function is easy to estimate once we have the TVC function. We can simply add TFC to the TVC function to get the TC function. Similarly, to obtain the ATC function, we can add the AFC to the AVC function. We can also obtain an estimate of the output level at which TVC is minimum or the point where the MC curve cuts the AVC curve. We know that the MC is equals to AVC at the point where the AVC curve reaches its minimum. Therefore, MC is equals to AVC, which is equals to A plus 2BQ plus 3CQ square is equals to A plus BQ plus CQ square, which gives us BQ plus 2CQ square is equals to 0, and hence Q star is equals to minus B by 2C. Q star here is the quantity at which the average variable cost will achieve its minimum. Mathematical example. Consider the following Cobb-Douglas production function that we have introduced in the earlier modules. Q is equals to 100 into k to the power half into L to the power half. Assume that capital is a fixed input and labor is a variable input, and also assuming capital to be fixed at 4 units irrespective of the level of the output, and the prices of capital and labor are given as rupees 4 and rupees 1 respectively. Total cost is equals to TFC plus TVC, which is equals to PL into L plus PK into K, which is equals to PL bar into L plus PK bar into K bar. Thus, TC is equals to L plus 4 into 4. This is equation 1. Q is equals to 100 into 4 to the power half into L to the power half, which is equals to 200 into L to the power half. Thus, L to the power half is equals to Q by 200. Hence, L square is equals to Q square divided by 40,000. This is equation 2. Now, substituting equation 2 in equation 1, we get the short run total cost function as follows. TC is equals to Q square divided by 40,000 plus 16. Thus, short run marginal cost function is given by MC is equals to delta TC by delta Q is equals to Q by 20,000 is equals to 0.00005 into Q. Short run average cost function is given by AC is equals to TC by Q, which is equals to Q by 40,000 plus 16 by Q. We can prove that MC will cut the AC at its minimum point. In other words, at the minimum point of the average cost curve, marginal cost is equals to the average cost. To find the output level at which average cost is minimum, we make the first order condition equals to 0 and then calculate the corresponding output level. We also test the second order condition, which should be positive for minimization. The first order condition, delta AC by delta Q is equals to 1 by 40,000 minus 16 by Q square is equals to 0, which gives us 1 by 40,000 is equals to 16 by Q square, where Q is equals to square root of 6,40,000, which is equals to 800. Second order condition gives Q is equals to 800. Delta square AC by delta Q square is equals to 32 divided by Q cube is equals to 0.0000000625, which is greater than 0. Therefore, at Q is equals to 800 units, the average cost is minimum. At now Q is equals to 800 units, the value of average cost and marginal cost may be calculated as follows. AC is equals to TC divided by Q, which is equals to Q by 40,000 plus 16 by Q, which is equals to 800 divided by 40,000 plus 16 divided by 800, which gives us AC is equals to 0.04. Similarly, MC is equals to delta TC by delta Q, which is equals to Q by 20,000, which is equals to 0.00005 into Q, which gives us MC as 0.04. This clearly shows that at the minimum level of average cost attained at Q is equals to 800 units, marginal cost and average cost are equal. Hence, it shows that marginal cost does indeed cut the average cost when the average cost is minimum. Summary. Let us now learn what we have studied in this module. Costs are very important element in the production and supply decision. With a given level of output, entrepreneurs tries to minimize the cost so that they can maximize their profits. Broadly, costs are of two types, explicit and implicit. Accountants do not measure the implicit cost, whereas economists consider both the explicit and implicit cost in decision making. This may cause a problem in estimation of true economic cost. The various measures of short-run cost are TC, TVC, TFC, ATC, AVC, AFC and MC. The shape of TC and TVC is S-shape. The reason behind this is the law of diminishing marginal returns. AFC is a downward sloping curve. The AC, AVC and MC curves are U-shaped. The reason AVC is U-shaped is the law of diminishing marginal returns. MC curve cuts the AVC and AC curves at their minimum point. Regression technique can be used to estimate the cost of production. There are two basic problems attached to the measurement of cost based on the actual data. First, recorded cost may not be adjusted for inflation, and second, economic cost differs from accounting cost.